Hi, hello, vanakkam, and welcome back to yet another episode on Little Slaw YouTube channel. And today is our day 4 on upskilling your knowledge on performance testing and performance engineering. So, previously on day 2, we saw about identifying the test environment, and on day 3, we saw about some of the questions which I wanted you to revise, or which I wanted you to understand, or which I want to make sure that you understand the concept which I have discussed with you on the day 2. So for that I have asked 10 questions and I have got few responses as well. Thank you so much for those who shared your responses, and now we will see the answers for all those questions which we have discussed. So coming to the first question, let me read the first question for you. So can you describe a scenario where the test environment significantly differed from the production environment during a performance testing project, and how did you handle this challenge? So this was a major question, and this is again a scenario based question that will be asked to you. And for this question, the answer goes like this. So for this, I will answer based on one of my previous example in one of my project. So I would answer like this way. So you can prepare your answers with the same one, or if you can relate some of your experiences, it's very well. You can relate it and you can answer it. So my answer to this question is, in one of my previous project, my test environment lacked adequate storage capacity compared to the production environment, and this leads to a performance discrepancies. So to address this challenge, I conducted a thorough analysis of storage requirements, and I worked closely with the system administrators to expand the storage capacity in the test environment. So most of the cases it will not happen, but still you can talk with the system admins, the DevOps people, or the operations who are in charge of the infrastructure. So you can discuss with them and expand the storage capacity in the test environment. Additionally, I adjusted the test scenarios to reduce the data volume requirements without compromising the test coverage. So after doing all these, I did regular monitoring and performance tuning, which ensured that the test environment closely mirrored the production conditions despite the initial discrepancies. So this is how I handle this scenario of test environment differences. So now we will move on to the second question. So the second question is, what steps do you take to ensure that the hardware configurations in the test environment closely resemble those of the production environment? So now we'll move on to the answer. So to ensure hardware configuration in the test environment to resemble the production, I leverage detailed documentation or system specifications provided by the infrastructure team. So this way, I ensure that the test environment resembles the production environment. So on top of it, I use virtualization technologies like VMware or Docker to allow me to replicate the production hardware configuration accurately. And after doing all these, I validate the hardware alignment through server audits by comparing the CPU, the RAM, and the disk specifications, because these are the parts that comprises the hardware. So after doing all these between the environments, by continuous synchronization and periodic audits, I will maintain the consistency between the test and production hardware configurations. And I will do all these to make sure or to ensure that the hardware configurations are aligned between the test environment and the production environment. So now moving on to the third question. So let me read out the question for you first. How do you simulate network architectures and end user locations in the test environment to reflect the real world conditions? this is again an important question when it comes to identifying the test environment. So when asked this question, I would answer in a way that I employ network emulation tools such as WAN emulators or traffic shapers to simulate diverse network architectures and end user locations. And these tools, which means these network emulation tools and the emulation tools, allow me to replicate varying networking conditions, including latency, the bandwidth constraints, and packet loss. So, in fact, if you have used your NeoLoad, you can even tell your tools like NeoLoad or your Blaze Meter or in Load Runner, you can emulate those scenarios where you can increase or decrease the latency, you can increase or decrease your bandwidth constraints like the Wi Fi, the 3G, 4G, 5G, and even the packet loss. And adding to it, geographic load distribution techniques like content delivery networks, the CDNs, which we commonly call as, or distributed load generators, which enable us to emulate dispersed end user locations. And network latency testing tools help me to validate network performance under different conditions, which ensure accurate simulation of real world scenarios. So these are the ways. These are not just ordinary ways. So these are very peculiar ways or very high technical ways which everybody should know or which everybody should have an idea or should have hands on to ensure that we emulate the real world scenarios, because it's not just only running a test with high bandwidth or with low latency or with proper with no packet loss. We should also do all these sort of mixer testing to emulate the real world scenario. And that's the third answer for you. And going on to the fourth question, so let me first read out it for you. Could you explain how you address load balancing implications in the test environment to accurately simulate production conditions? So, this is another important question that you might come across in your interview in any other way. So, to address load balancing implications in the test environment, I verify the load balancer configurations against production settings. So, that's the very first thing. I will start collecting the data on the load balancing configurations against the production settings, and this involves validating the load balancing algorithm. So you should know what is the load balancing algorithm that is being used. You should understand the session persistence settings and the health check configuration, because load balancer performance metrics are monitored during testing to ensure even distribution of traffic across backend servers. Additionally, I will conduct failover and scalability testing to assess the load balancer resilience under varying loads and failure scenarios. So, by doing all this, I will address the load balancing implications. And now I will move to the fifth question. So, the fifth question is, what considerations do you take into account when selecting and configuring load generation tools for performance testing? So, this is another important question, I would say, because most of the time people will ask you, like, on what criteria or what basis do you select your load testing tool? So, when selecting load generation tools, I consider factors such as protocol support, the scalability, the scripting capabilities, and resource consumption. Say, for example, Neoload supports web application, APIs, web services, but Neoload does not support mainframes. On the other hand, JMeter supports web applications, even mainframe to some extent, and it also supports a lot of connectivity to performance monitoring tools like App Dynamics, Dynatrace, which even other tools in the market do lack. Same is the case with LoadRunner. LoadRunner supports every protocol in the world, you would say, but still, even LoadRunner has few limitations. So you have to list down all these. You have to list down the protocol support, the scalability, the scripting capabilities, and the resource consumption. On top of it, the budget. So JMeter comes as an open source, we all know. So it's free of cost. So popular tools like JMeter or Gatling, they offer robust scripting capabilities and support for various protocols, which makes them suitable for diverse testing scenarios. And the configuration involves defining realistic user behaviors, their ramp up patterns, and workload distribution to accurately simulate production loads. And load generator instances are distributed across multiple machines to distribute load effectively and prevent resource bottlenecks. So, this is just an example. So, in case if you use any other tools, you can very well tell your advantages are the reasons for choosing it. For example, if you are choosing new load, I would say 99% or 95%, it does not require any code, and new load supports new load web. JMeter lacks it. Loadrunner has that option where you can do your testing in a SaaS model, in a service as a software as a service model. Even new load web does it. So you have lots of options. So you have to come up with your options when you are selecting a tool. So you have to tell all these scenarios. And that's the fifth question and answer for you. And moving on to the sixth question. So first, let me read it for you. The sixth question is, how do you handle environmental impacts caused by performance monitoring tools during testing? So I feel this question is quite early for you because there is a lot of areas to discuss, but still, I would really want you to have a pitch in on this question early. So coming back to the handling of environmental impacts on monitoring tools. So to minimize the environmental impacts caused by monitoring tools, I carefully select the monitoring metrics based on test objectives and system requirements. And monitoring overhead is reduced by adjusting the sampling rates, filtering irrelevant metrics, and prioritizing critical performance indicators. So I schedule the monitoring activities during off peak hours to minimize the interference with test execution. Continuous monitoring of resource utilization helps me to identify and address any performance degradation caused by monitoring tools during testing. And that's the sixth question and answer for you. And moving on to the seventh one. So the seventh question is, can you discuss methods for validating name resolution with DNS to address latency issues in performance testing? So I validate name resolution with DNS by verifying DNS cache consistency by measuring round trip time for DNS queries and conducting server configuration checks. So why do I do all these? Why do I measure the round trip time for DNS queries and conducting DNS server configuration checks? Because this process will ensure that DNS resolution latency is accurately represented in performance test. And I also perform load testing on DNS servers to assess their capacity and responsiveness under load. Additionally, I simulate DNS failures to evaluate application behavior in scenarios where DNS resolution is unavailable or delayed. So now moving on to the eighth question. How do you ensure that firewalls, routing, and other network components treat generated loads similarly to real production traffic during performance testing? So this is another important question because whenever it comes to comparing to your real world performance testing, you should really add some value to it. So to ensure the network components treat generated loads similarly to real production traffic, I validate the firewall rules. That's the first thing. And then I will check the routing configurations and network traffic shaping policies against the production standards. And this involves reviewing firewall rule sets, inspecting routing tables, and analyzing network traffic patterns. So I simulate various network conditions such as congestion and packet loss to assess the impact on application performance. And by doing continuous monitoring of network traffic during testing helps me to identify any discrepancies between simulated and actual production traffic behavior. Now, moving on to the ninth question. Could you describe your approach to identify critical system components and integration points for performance testing? So, how will I approach it? So, I identify the critical system components and integration points through comprehensive system architecture analysis and stakeholder consultation. So, I do this regularly to identify for any critical system components. And this involves reviewing system documentation, conducting interviews with subject matter experts, the SMEs, and analyzing system dependencies. I then prioritize the testing efforts based on criticality and risk, and I focus on components with known performance concerns on high impact on system performance, and integration points are thoroughly tested to validate data exchange and communication protocols under load. And now, moving on to the last question. This is quite simple, I would say. It's very easy to answer. So how do you collaborate with IT staff and system administrators to optimize the test environment for performance testing? So, since I told you it's easy, the process is easy, but still, we all should definitely do it. So, I collaborate closely with the IT staff and system administrators to optimize the test environment for performance testing. And this includes establishing clear communication channels by defining roles and responsibilities and providing necessary documentation and training. I, in fact, engage with the IT personnel in tasks such as infrastructure provisioning, monitoring configuration, and troubleshooting. So, in my regular meetings and status updates, I ensure an alignment between the test objectives and IT support activities. And by fostering collaboration and teamwork, I ensure a smooth and efficient testing progress. So, with that, I come to an end of this video. I definitely believe I would have brought a lot of information to you. So, thanks again for your support on all these 3 days, and thank you so much for your continuous support. And in our next video, that's day 5 video, we'll move on to the next topic. Until then, it's bye bye from Vasan Shanmugam and Little Sla.